Okay, so we're looking at Chapter 1B, Lesson 6, Task 2, and these are GCSE example questions, and these are actual questions that have come from previous papers. So one of the ways that they set out this question was they gave you numbered pieces of information, and they wanted you to put it in order of the blood flow through the heart. They gave you the first one, and they gave you the last one, and then you can see here it's worth a total of 5 marks. So it's really important that we understand how much it's worth and what it needs to go into. So there's 2 ways I did it. First of all, I made sure I was ticking them off as I was going through to ensure that I wasn't missing anything. And then I went back over to the end. So what they want us to do is they want us to start off, first of all, with the deoxygenated blood at the right atrium. Now, hopefully you'll remember now, it goes from the right atrium into the right ventricle. So that was number 4. That's the pathway through the blood. Now, which we've done before. Now, if it's deoxygenated blood, at this point here, it needs to travel to the lungs because it has not got any oxygen. It needs to go to the lungs. And the way that it's going to do that is pulmonary, which deals with anything to the lungs, and an artery because it takes the blood away. And that brings us to number 7. Now, once it's gone to the lungs, we're going to experience what calls gaseous exchange, where the carbon dioxide is going to be removed, and then we are going to have an uptake of oxygen. So that will be number 1. Now it needs to go back to the heart because we're running out of pressure. So there's no way of getting it to the working muscles without getting it some more pressure back. So it's going to go back in. So it's coming from the lungs. So at this point here, it needs to go to the heart. But because it's come from the lungs, it needs to again be dealing with the word pulmonary, and then a vein because it brings the blood into the heart. That's number 1. Then it brings us to number 5, and we're done. Then at this point here, if it's travelled into the right atrium, then we know that it needs to go, left atrium, we know it needs to pass down to the left ventricle, so that's number 2. And then this oxygenated blood is then ejected from the heart via the aorta, which is point number 6. And that is the order, but make sure that you can see that you're highlighting and ticking as you're going through and to make sure you're not duplicating any of the work. The next question was about a spirometer, which measures our volume regards to our lung capacity. We've got a number of different volumes here. Tidal volume is the volume per breath. Residual volume is a volume which always remains in the lungs, so they don't get sticky. And the 2 they asked for in the middle were our inspiratory reserve volume and our expiratory reserve volume. So tidal volume is at normal breath, and then you can see there's been a change in this volume at exercise. And that again, which we talk about, is supply versus demand. I am demanding more oxygen because I'm exercising, so therefore my tidal volume has got to increase. When I'm taking a normal breath, I've not filled my lungs to capacity. There's always space for me to take a little bit more, and that is the inspiratory reserve volume. And then when I exhale, I can always exhale a little bit more. That would be my expiratory reserve volume. Now, another question also came up was to comment on what happens to these 2 volumes during exercise. So if you compare the range of X at rest compared to the range of X at exercise, we can see that inspiratory reserve volume decreases during exercise because my tidal volume has increased. And the same here, the volume of Y has decreased significantly at exercise because I'm eating into that additional space. And the final question was about the circulatory system, about how it works as a double pump. So we have both sides of the heart. We have the left side and we have the right side of the heart. So the left side of the heart, I put that the wrong way around. So we have one side of the heart that deals with deoxygenated blood, and the blood comes into the heart through the vena cava and it leaves the heart through the pulmonary artery. And again, because it's the word pulmonary, it's going to be heading to the lungs to pick up the oxygen. And that side is the right side. Sorry about that. The left side deals with oxygenated blood. So the oxygenated blood has come back to the heart via the pulmonary vein, and then it leaves the heart via the aorta to working muscles. Now, because we have this double-sided, there isn't a delay, it's constant. If we think we have lungs, heart, body, it's heart, lungs, heart, body, body, heart, heart, lungs. And they're both going on at the same time. So there is no delay process. We've got a double pump happening. And then if it's coming up to here, this is deox. Then it goes to lungs, it gets oxygen. It goes to the body with the oxygen gets used up, and then it becomes deoxygenated blood. So you have two sides, one that deals with oxygenated blood and the other that deals with deoxygenated blood, and that is how we have a double pump action in the circulatory system. So this is chapter 1b, lesson 6, task 2.